All right, so we've gone over a lot of the major parameters that are typically measured in an aquaculture system. Now we're going to talk about how you measure them. There's multiple ways of measuring almost all of these different ones. We tried to list up here most of the ones that we talked about. So we're going to see what you guys know that what you can use to measure it, and then we'll fill in and I'll show you some examples of those that we have here. So let's go ahead and start from the beginning. How can you measure temperature? So typical. Usually you get an alcohol thermometer now, but it used to be mercury. You just put it in there, see how high it goes up, and that's great. But a lot of these other things actually tell you the temperature as well. It's still a thermometer, but what else? It's not necessarily a glass-filled tube. Digital probe. Okay. Digital probe. So a lot of these meters have a little just digital probe that's a little metal thing with two wires coming out of it that'll give you the temperature. I have some that are just straight temperature that you can hook up to a controller of some sort. Any other ways you can think of to measure temperature?
Yeah, I was going to say get your finger in.
Right. The old feel test. All right. How about, so we usually talk about salinity, right? But I lump those together: conductivity, salinity, and TDS. What's TDS? All right, good job. All right, give me some ways to measure those.
What's TDS means?
Well, I'm looking at this kit right here. This
All right. Which one?
This little blue kit right here to your left.
Right,
This one?
Maybe, yeah.
Salinity, okay. So this
Jesus.
has a demineralizer in it and a titration reagent A, B. I wouldn't recommend using this. It looks like it's seen better days. So it's got multiple reagents. And so these are these little titrators. So they have a scale on it. You fill it up with a reagent and you squeeze it out till you see a change in color, right? So that's what a titration is. You mix two things together till there's an endpoint or a color change. And so you can do that with salinity. Again, there's a demineralizer and then two reagents, which have definitely leaked all over this thing because they're old. So there is a salinity titration. That is one way to measure it. Does this seem like the easiest way to measure it?
No.
No. Okay, let's think of an easier way.
Refractometer.
All right, we use those in lab. We saw the principles behind it. You got your refractometer. It's got a little lens here. Put your sample of water on it. Look through it. The change in the reflection of the light is going to read on a scale on the inside. What's it important to do before you put your water from your aquarium on here?
Clean it.
Clean it
With water.
with fresh water, and then what?
Wipe it dry.
Okay. Then
Make sure
what?
you cover the entire surface.
Yeah. There's a sample that you should do before you put your
Oh,
tank water on here.
Zero.
Zero it. We use the fresh water. Check to make sure it's zero. That means that your scale is correct. There's an adjustment. Make sure it's on there. Okay. Calibration, important everywhere. So refractometer, number 2. What's another method?
Hydrometer.
A hydrometer, okay. This is a swing arm hydrometer. So it has a little plastic thing with a disc on there that has a certain density basically, and it floats up and it reads on where the tip of this is, reads on that scale and tells you the density, which is also related to salinity. This one does go from 0 up, but some of them only have a range that doesn't start at 0. It starts at some sort of medium salinity up to a higher salinity because it's hard to get a fine measurement at these lower ones. Biggest source of error I see with these is you get an air bubble on the arm that's going to make it go way up to the top, and you kind of got to knock it off. Was there another type of hydrometer that we saw an example of? I have one back there. I forgot to bring it out.
Oh, the glass hydrometers.
Okay, so that has a weighted bottom, has a certain density. It'll float up and down, and there's a scale on the thing. How else could we measure conductivity?
Probe.
All right, so to conduct electricity, you're measuring the ability of it to conduct electricity. The electrical conductance meter. There are several different types of them. Most meters that are going to tell you salinity are really measuring conductivity and then doing some calculations in there. I found some really old school conductivity meters that we had around here. What did I do with that one? So this thing here has a little probe that you put in the water, and it's basically just a little metal rod inside this tube, and it would send electrical current into the water, and you turn it on and you adjust these knobs until the red light comes on, and then that's how much conductivity is matching. So this is kind of neat. I have never tried it, but
So you have to do the calculation then?
well, okay. Let's see. You tell it the temperature. A lot of these are temperature compensated. The fancy new meters are temperature compensated, but there you had to take your thermometer, measure the temperature, and dial this to the temperature, and then put the meter in, and it would tell you the conductance in micromos. So that's old school. There's another one here where you actually kind of do the same thing, but you put probes into the water, which I don't have anymore, so that's like a really old one. But nowadays, it just looks like this. You turn it on. There's a little probe here. It's the same idea. There's two holes, and it sends an electrical current through the water, and it measures how much transfers across, and it just gives you a readout here. It also measures temperature, so it can do that compensation for you. And you can either measure the straight conductivity or the temperature compensated conductivity, which I think like 25 degrees is sort of the standard. And it'll also tell you, it'll convert it to salinity for you. So this is a meter that measures all three.
One thing I want to mention about the chemical titration is that it's really, I think what it's testing is the chlorinity. It's a chemical test for the amount of chlorine. So it means it's only effective for seawater. You don't want to use it for any other situation. And the reason it's effective for seawater is because even though salinity can vary greatly, in seawater, the proportions of those top 6 most abundant ions is the same wherever you go. So if you can test just for one of those, and chlorinity is the easiest one to test for, then you can extrapolate and calculate the overall salinity. The problem is, one of the problems is that the chemical reagents are pretty bad. They're not the kinds of things you can just dump down the drain without doing some real environmental damage. So most places have stopped using them, except as, sometimes a demonstration, but it's an expensive and messy and overly complicated way of measuring salinity.
And oftentimes in freshwater systems, because you're talking about really low concentrations, they're really measuring the chloride. They call it chloride ion is what you're measuring instead of chlorine. All right. Any more ways to measure conductivity, salinity?
You can use a spectrophotometer, can't you?
All right. Excellent. What is a spectrophotometer?
Those light waves.
All right. this is a smallish spectrophotometer. We have some actually really big ones out in the other room as well. What it is taking is, it has these little cells, cuvettes they're called, and you put your sample in here, right? That has the water sample has its own kind of color to it, right? Ability to reflect or refract light. And so first you take your blank with just the water sample in it, and then you add your reagents to it. It goes through a color change, and then it'll measure the absorbance at a certain wavelength. So these things have the ability to measure hundreds of different water quality parameters or different contaminants that might be in the water. Each one has its own set of a set wavelength that it operates at. It operates at and different reagents that it uses, and usually that you add those reagents so that like a reaction will complete, a full reaction will happen, and the amount of color change impacts the thing. And so they usually have a range that they're effective, where if it's outside of that test range, it'll be too dark to measure or too light to get a good reading. But there's literally just, this is a small book. There's larger books for some of the other tests for spectrophotometer. So spectrophotometer is the answer for a lot of these. I've never measured salinity with a spectrophotometer. You probably can. If you can do a titration, or you can do a like a dropper test kit, you can probably measure it with a spectrophotometer.
And I think there are some parameters where you don't even need reagents. It's measuring the absorbance, and which can change based on, and I don't know which parameters because I don't use it much. I figure it's not, if it's not saving me using reagents, it's not saving me much.
Yeah.
Like TDS and the color, the actual turbidity of the water is definitely something you can just directly measure with the spectrophotometer.
And also, I threw up there versus colorimeter, which is a similar kind of thing. Do you have one or want to say anything about
This one is a colorimeter actually, and the larger one is a spectrophotometer. Do you want me to like come up with off my head what the difference is?
Well, no.
I'm not sure I can do that.
The way I explain it for a colorimeter is basically you maybe you've all done a chemical test, even if it's just your very first test on your tank in there. You add some reagents and you mix it up and you wait and you look and you're comparing it to a chart, and sometimes you think, I'm not sure if I'm colorblind or if I can't match it to one on. It's hard to read the colors, and we all see colors a little bit differently. And the way I see a colorimeter is really, it's something that basically reads very precisely that color change for you. And the color that you're seeing really is just about which wavelengths of light are being absorbed versus transmitted or reflected back out of there. So I think it's just a fancy way of more precisely reading colors for some of these tests. Of course, maybe I'm wrong about that.
I just don't know what's different about a spectrophotometer, but it's doing something similar, same principle. All right, pH.
pH meter.
A pH meter, all right. So this is a pH pen, which you can get, and same idea, a pH probe that you can attach to any kind of handheld meter. It has a little glass ball on it, and it measures by electrical current, basically how many of those hydrogen ions are around it. How else could you? What also do you have to do with this before you use it? Calibrate, calibrate, calibrate. Definitely get drift on a pH meter between uses. How else could you measure pH?
Test strip.
Okay. So this is the idea of a little, usually they have a pretty different, maybe not high resolution measuring, but if people use them for your pool or whatever to figure out what range they're in. This scale on this one for pH is every 0.5, so it's 6, 6.5, 7, and it only measures between 6 and 9. So you don't get a lot of high resolution with this, but you can check that you're not pouring straight acid into something, I guess, or whatever. What else?
Liquid test kits.
Okay, there's dropper test kits. You can buy all individual boxes of the different tests. This is a big test kit that has all sorts of different ones in it. They measure color changes, like he was saying, that you compare. There's different brands that use slightly different methods. Some of them have a card that you look at. Some of them have sample vials that you compare it to, depending on what, or color wheels. There's lots of different ways to measure it. But there is a dropper test kit that you can do, look at the color change and measure it. They're usually different for freshwater or saltwater, high range or low range for pH. Any other for pH?
Spectrophotometer.
Just gonna draw an arrow out here, because
Yeah.
you can use the spectrophotometer for
Pretty well everything.
pretty much everything on this whole list.
Test strips as well, right? Where they for alcohol, right?
Definitely for alkalinity, definitely for hardness. I think they can make them for those, but they're I don't know if there's enough of a demand. They make something called an ammonia badge that you hang in the tank, and it will change. You know, it's not an instant test like a test kit. I mean, like a test strip.
They make those for
But
pH too.
it works. It's not super precise, but it'll give you an idea. Hey, there's ammonia climbing in here. We better do something.
All right, alkalinity.
Titrations.
Okay. Primary way of measuring alkalinity is with titration. There's different types of titrators. A lot of what we have is Lamott brand. There's also Hach, H-A-C-H is another brand of test kits. Their alkalinity is a digital titrator. It's got a little knob that squirts out a little bit of acid at a time until you see that color change, and then it'll just give you a number. This one is, again, using the little scale on the syringe, and you add your indicator. It'll change blue, and then there's your color change card that should be in here. Goes from basically blue to purple to pink, and at that interface between pink and purple, you are there. Any others for alkalinity? Right, spectrophotometers for all of them. There's not really any meters that measure alkalinity directly. So titrations are the primary way of measuring alkalinity. Dissolved oxygen.
Titration and a meter.
Okay, so the Winkler titration, right? I don't know if any of you have done that in like high school chemistry labs or whatever. You get your reagents that you add a little bit at a time, and there's a whole calculation involved and stuff. There is again, the little kit like this, the dissolved oxygen kit, which has the same a set of reagents that you add at different, following the instructions is very important in all these tests. Reading the instructions thoroughly to what kind of other interactions that could be. Some of these will work or will be thrown off by other levels of certain chemicals being high. If there's if it's a high calcium, you won't get a good alkalinity reading, or whatever it is. There's a set of conditions it'll work properly in, and that's what it's designed for. But they're basically, again, a set of there's a titration or a meter. And there's multiple types of dissolved oxygen meters. We'll start with the old school. Oh, I forgot to show you my old school pH meter. It has a little like
Oh, nice.
digital scale and very kind of looks like a radio, but it still has the same kind of probe that you would use today. It's a different. So I really don't know enough about this to tell you how it worked.
That's a DO meter?
Dissolved oxygen and temperature monitoring field unit. It is it looks like it's going to be measuring some sort of conductivity through the water. See what this probe looks like. So the main types of this is the batteries, and this must be the unit. It's just I guess it must be a membrane unit. So there's basically a little like electrode here, and then it has a membrane, and it draws the oxygen across the membrane and measures the rate at which, or the number of oxygen molecules, or how much conductance you get. So there's a few different types of membranes that are out there. There's the galvanic membranes, and there's a polarographic, just different configurations and different materials used. And then one thing that we just got, and so with those meters, there's a solution, a ionic solution that you set on top of the electrode, and then you stretch a basically plastic membrane with very tiny holes in it across that, and then it measures, and then it can pull oxygen out of it. So you have to calibrate it. It takes a long time to warm up. You have to change those membranes, and it's very kind of a pain in the neck to work with. This is an example of a newer model of that has under here you put the solution, and then you stretch that membrane across it, and this is a little like O-ring that holds it in place. And so you can pass that around if you want. At some point I'll make you change the membrane, drive you crazy.
Yeah, well.
Because if you get a bubble or a wrinkle or anything like that when you're stretching the membrane out and pulling that little O-ring over, you got to start over. But the newest meter that I have is called an LDO meter, or a light. It uses a light sensor, and it doesn't have a membrane on it, and you don't have to let it warm up, and it doesn't. It lasts a year, and then you change it out. And so you just turn it on, and you get a measurement right away. It's much more user-friendly and less maintenance than that other meter. So I'm very excited to have this. So multiple different kinds of dissolved oxygen meters, all kind of using some sort of conductance or kind of direct measurement of the oxygen in the water through the light penetration. Ammonia. What can you think of for ammonia?
The dropper test thing we did with it.
Okay. So that is a sort of a dropper test kit. How many different bottles did you have to put in for ammonia? 2. So you put reagent number 1, reagent number 2, and it reacts. What color does it turn if you have ammonia? Green if there's ammonia, yellow if there's not. The spectrophotometer test, again, same idea, same reagents, the whole 9 yards. It's just it's getting a better, more precise reading. Again, the range of the test is important. If you're outside the range, and that's why we kind of did it systematically, because 8 is dark green. But you don't know 6, 12, 20 probably is all dark green too. So you really need to figure out where on the scale you need to be. How would you adjust if you had a high concentration and you wanted to know exactly what it was? What would you do before you tested?
You dilute it with 50% deionized water.
Okay, so you make a dilution factor. So maybe it's 50%, maybe it's 1 milliliter of sample into 9 milliliters of deionized water, and then you multiply your answer times 10. But you dilute so that you come down into the test range. So we've got dropper test kit, we've got the spectrophotometer, any other ammonia test that you know of?
They've got the badges,
The badge that he was talking about, okay, that changes color.
strips.
Strips, and so ammonia, you got the badge, the strip, and they do make a probe that supposedly measures nitrogen. I've never used it. I couldn't tell you. I couldn't really get enough information on it that it like would tell you the ammonia that you wanted to know.
What badge are you talking about?
It's a silly name. It's only one company that I know makes it. It works like a test strip. It's just a piece of plastic that you put in the tank, and it's got a little pellet on it that changes color if the ammonia starts to come up.
Okay.
And it gives you a very rough estimate. It has like
Once it
4
comes out,
numbers
it's a
on
one
it.
single use thing. Once it changes, you got to throw it away.
No, I think you can leave it on for a few
It'll change
months and
back.
it'll change back. Yeah. Use it like it's kind of like an alert. It's not to test how much ammonia. It's to, you walk by the tank and it catches your eye that it changed color. Something's wrong.
More of a range than a,
Yeah, it's an
indicator that ammonia is
consider it
present.
a qualitative test. That's not for measuring. It's just there shouldn't be in a stable system. Unless you make a big change, a big harvest, overfeeding, a fish kill, there shouldn't be a change in ammonia. It shouldn't come up in a well-established system where you haven't done anything. So, but sometimes there's a pile of fish somewhere out of sight that you don't see dying, rotting, and this can bring your attention to something like that.
All right, nitrite and nitrate, we can do those together because they basically have the same types of tests.
Strips, liquid tests, spectrophotometer,
strip.
And so with the reagent, sometimes there's a liquid reagent, and sometimes it's a powdered reagent, depending on the manufacturer and the test. So, and the different manufacturers that use the colorimeters, Lamont has these little tiny spoons that measure out a certain amount that you add, and Hach uses these little packets, powder pillows they call them. You cut them open and pour each one out, and it's really about which one works best for you. It's still kind of doing the same thing, giving you that color change, but they can be different. They can be the same chemical reagent, but in different forms. How about hardness? We'll lump calcium in there.
Strips.
Okay,
There's a strip for that.
there is a strip. What else?
titration, isn't there?
The chemical test is a titration.
There's
on
a
that, right?
titration, yep.
Do you understand the difference between when we say a reagent test kit versus a titration? Both ways you're adding the reagent. In a normal reagent test kit, you're adding a measured amount of reagent and looking for, you're looking to match a color. In a titration, what you're measuring is how much of the reagent you have to add before a color change happens. So they're both chemical tests, but they work a little bit differently. And
So this one's a reagent test for calcium. And then I have another one that is a titration for calcium. So they do make both those for hardness of calcium.
I threw out another parameter. I forgot was in, but just last week. What's turbidity?
How clear the water is.
It's a measure of how clear, or technically it's how unclear the water is,
Yeah.
right? You're measuring, so turbidity would be the opposite of, what would you say would be the opposite of turbidity?
Transparency.
Transparency, right? If so turbidity is measuring how murky the water is. What causes turbidity?
Biofloc, like phytoplankton.
Yeah, anything that's alive and suspended in the water, or anything else that's suspended in the water, little silt particles or clay particles, or just organic molecules, but living things or sediment stirred up. The water's always more turbid after a storm when sediment gets kicked up into the water. So it's a very general term. It can be caused by anything, or any number of small particles. And there's a few different ways to measure it, but the simplest and cheapest way to measure it.
Does anyone know what this thing is?
Looks like my wheel that I put from my Christmas tree. Spin directly.
It's called a Secchi disc.
Secchi.
So it's obviously just black and white sections of a circle. It's got a weight on the bottom, and you lower this into the water, and the point at which it disappears from looking at it from above is the Secchi depth. And so obviously if it's really clear water, you'll be able to see it very far down. If it's very turbid water, it'll disappear pretty quickly.
That's
And
like
so
30 feet then, or 30 something. I seen a video that they done that.
yeah, they
In the
do.
murky
This
water.
is if you're out doing any kind of biological sampling or water sampling, this is something they usually carry with you. This is graduated.
Yeah.
The line has marks every like 1/10 of a meter, so you can, and then like it's red at the 1 meter mark, so you can get your actual Secchi depth. How else might you measure turbidity?
Turbimeter.
A turbidity meter.
30 meters.
Do you even have an answer?
So what is that actually doing?
50 meter.
It compares the refraction of light at a 90-degree angle. The water sample that's out of a sample of clear water.
That was wiki amazing. Oh, the book, sorry.
Yeah.
Or an index in the back. For those
Sure
of you
is.
that are addicted to Google.
So the light penetration through the water is basically what the meter is measuring.
Does it say what the units would be if you're using that? We should put units for all these things.
NTU.
NTU
I'm
it
not
is.
even gonna pretend to pronounce the first words.
Isn't it National Turbidity Units or something like that? Or?
Yeah, meter or something.
We'll just call it NTU.
I like that.
Degrees
I
hardness.
cannot.
Hardness, all of these would be in
Or
parts per million,
Or
right?
CaCO3.
Or-
ppm CaCO3.
Weight suspended.
I like that though. Yeah. They're calling it that.
ppm on the
Or milligrams per liter, yeah.
She's got ringtones for every song.
Yeah, ringtones for other products. She knows the answer.
what are we doing? What's milli equivalence for ppm?
Yeah. Usually probably, yeah.
Yeah, Elvis Presley on there. There's no one.
It's just the numbers.
All right. Any questions? Anyone can think of some other magical water testing? All right. That's all we're going to do for today. Again, come see me.